Welcome back, everyone. So before we start the wireless project, the Toronto office, we're thinking of making it wireless rather than having an Ethernet or wired LAN. Let's take a look at some wireless concepts so we can at least get our idea how wireless technology works. Now, scientists tell us that there's something called the electromagnetic spectrum, okay? And an example of electromagnetism is light, ordinary light that is received by our eyes. And the difference between the different colors, let's say between green and purple and orange, is the wavelength, okay? So light is a wave or a disturbance that occurs in something called an electromagnetic spectrum. And some light waves, well, they're kind of stretched out. They have a longer wavelength, and some are more squished together. And the eye perceives these different wavelengths as light. So the light that our eye receives is in this range here, and you can see the scale. Okay, nanometer means billionth of a meter. So purple or violet is about 400 billionths of a meter, whereas red and orange is in this range here. The wavelength is more stretched out, about 800 nanometers. And you can see here that when you go beyond purple in this direction here, when you make the waves more tight or smaller, you enter what's called ultraviolet rays. Now, human beings cannot see those colors. Maybe some animals or insects can, but certainly human beings cannot. And likewise, when you go in the other direction, beyond the red, you end up in what's called infrared, and you're stretching out the wavelengths, making them longer. Again, human beings cannot see those particular colors, but they are there. And we can keep going here, stretching out the waves further, making them much bigger, or making them more compressed. So as we make the wavelengths of electromagnetism tighter, we get into X-rays and gamma rays, and we refer to these rays here, this type of electromagnetism, as ionizing radiation. It can cause genetic damage and cancer. If you go in the other direction, over here, you have radio waves, and you can see here, these radio waves are on the human scale, 1 meter, 10 meters, 100 meters, and even many kilometers. Now, the reason why we're mentioning the characteristics of the waves is because it affects its properties. Can those waves go through solid objects? Can they go around a mountain? How far can they travel? Well, that's all determined by these wave characteristics like wavelength. So an early form of wireless technology was infrared, and we don't use this much anymore. If you have a remote control for a television, you might have an infrared port, and if you look at it, you'll see a black panel on the device, and it was a very early form of wireless communication, and it had a few problems. It could only communicate short distances, and it was not able to penetrate through objects, through walls. So if you have a remote control and you go to another room in your home and you try to change the channels for your TV, it doesn't work. You need something called a line of sight, where there are no obstacles, no walls, no objects. And here's an interesting experiment. Infrared bounces off of mirrors. So if you set up some mirrors in your home, you could go to one room and have your television set in another room and point the remote control for your television set at the mirror and bounce it off towards the TV and change the channel. So that's That's a nice experiment you can do with infrared. We might see it today with a wireless mouse and a keyboard, but we're not going to see it, we're not really going to encounter it too much. So infrared is over here on the spectrum, okay? So this is in the part beyond the visible spectrum, and the wavelengths are somewhat larger. What we do use in wireless communication more often is something called radio frequency. So up here on the 1 meter scale to several kilometers, this is the range in which wireless networks communicate. And you can see here that it operates on different channels, 2.4 gigahertz to 2.483. So that is one major channel that we have in wireless networking. The other one is 5.7 to 5.8. And these standards are determined by a committee or a consortium called IEEE. Now, I have a terrible memory. I don't remember a lot of things, but this is something that I remember. This number here, 80211. That is a number worth remembering because that refers to wireless networking. Wired networking or Ethernet is 802.3, but when we're talking about wireless, it's 802.11. And we have many standards. Okay, so if we come to this page here, the original 802.11 was released in 1997. And you can see here its frequency. It didn't transfer too much data. And I remember I remember in the 90s when this first version of wireless came out, I begged the IT manager to make our office wireless, and he refused. And I really didn't understand at the time, but I think I know what the problem is now. The problem was really security. Well, in 1999, the next version of 802.11 came out. It was the 11A, and you can see we had a big jump in network or data rate, the data transfer rate, 54 megabits per second, and again later that year, the 11B was released, and then in 2003, the 11G, and so on. 11N was around for many years. It was originally released in 2007, and it was only recently that the 802.11ac was finally released. And let's go now to a website. Okay, let's go to Best Buy, or you can go to eBay, and let's look up a wireless device. So I'm going to go to their shopping link. And I am going to go to computers, tablets, and accessories, and I'm going to look for Wi-Fi and networking. So that's what we're interested in. Let's click on Wi-Fi. And we'll give the page a minute to load up. And I'm not going to be very picky. I think I'm going to just click on the first wireless device I can find here. So let's click on wireless routers and find any wireless device. So let's choose this one right here. Okay. And I'll show you some of the things that we need to look at when we're shopping around for wireless devices. Okay, so if we click on details and specs, okay, we need to know something about the coverage, how many square feet, and you can convert that to square meters in Google. The wireless standard, This is very important. And the most recent wireless standard is AC. Okay, so that's what you really want to see. If I don't see AC there, I'm probably not going to buy this device. And it's backward compatible. So all the older standards, if you have a wireless network card that is compliant with 802.11b, G, or N, you can also use this router because it is backward compatible. And you can see it operates over these two different frequencies, 2.4 gigahertz and 5 gigahertz. So those are the important things we really need to take note of: the coverage, the standard, the channel. Okay, and that's why we see two sets of antennas. So this pair here might be 2.4 gigahertz, and this pair over here would be 5 gigahertz. And finally, the Ethernet speed. So we have 10, 100, and 1000 megabits per second. So that is a summary of the specs on a wireless device. Let's return to our presentation. Okay, now what types of wireless networks do we have? Well, they're not clearly defined. There's something called a PAN or a WPAN, a wireless personal area network, and it's not a network at all. It's just your mouse and keyboard communicating with your computer. And then we have WLANs, or wireless local area networks, and then WWANs, wireless wide area networks. And these are not clearly defined here, but the range, okay, the distance that you can communicate with wireless devices is impacted by background electromagnetic noise, solid objects, temperature, humidity, and a few other factors. Okay, so I think that should get us started with the wireless project. I'm available all day if you have any questions. It is a difficult assignment. Collect all the information in it and upload it in Word or WordPad. And tomorrow we're going to use that information for our final project.